Good morning, good afternoon, good evening, depending on where you are in the world. My name is Don Bowman. My company is Agilicus. And today we're going to talk about some of the bread and butter information systems that are associated with public water systems. So HMI, PLC, SCADA, Modbus. And in particular, we're going to talk about how they interact with modern cybersecurity and how we can achieve some of the goals that they're multi-factor without reworking those things. So no native support, no problem. So the first thing I thought I would do is I thought I'd just cover kind of the current state of the world. So SCADA, Modbus, Ethernet IP, they were all designed from the start for strong security with single sign-on, multi-factor. Every RTU and HMI, they have frequent, easily installed security patches that never break anything, and management always allocates enough time and resources to stay secure, and documentation is always perfect, and testing updates is trivial. Turns out none of those statements are true, and it's close enough to April 1st that I felt April Fool was an appropriate AI-generated image on the right. But it's all false. From the very start, things like Modbus, they were designed for a simpler world. It was originally designed for serial ports, and there was no concept of somebody getting in there and attacking it. And when you talk about like an RTU, if it sees an update in its lifetime, you will be considered lucky. And if it does have one, the release notes are going to be 10 paragraphs of what not to do and one line of if something bad happens, and that's just going to be the end of the world. And everybody's going to be saying you don't get any time to do patches or updates. Of course, make it secure, but you're never out of service. And as far as documentation goes, that thing that was printed up and rolled up in the bottom of the cabinet a decade ago, there's been a lot of people in there poking around and moving wires over the years. So, good luck for testing your updates. So this is the world we live in. We live in a world where the things that we have to use to do our business are insecure, and there's people that want to attack us. And today I'm going to talk about a way to up-level their security without changing their configuration, without changing how they function, without reimagining the plant. So the agenda today, this is, it's about public water systems, but you could really put in any industrial environment here. It could be energy, it could be manufacturing, it could be something else. They're all very similar. Building management systems often are very similar as well. So we'll talk a little bit about the motivation of why we want to improve our security stance and why we have to do it within the realm of how things work rather than reimagining them. There are people reimagining it, Industry 4.0 and so on, but today I'm here to talk about what we're running today. An overview of the problem, we're going to talk about some of the specific technologies, and there's going to be a demo. The demo is going to try to drive home how it is we can do multi-factor authentication for a Rockwell panel view, HMI, for example. So motivation, take any motivation you want. The alphabet soup of agencies recommends that you put multi-factor on, that you improve your cybersecurity, that you do patches more often, that you don't show up on the public internet, that that you have single sign-on, and they each have lots of good reasons why they do that. The news is constantly warning us and scolding us and reminding us about the sky is falling and what's happening there. There's regulatory rules that are in play in some jurisdictions, and probably most importantly, there's people out there that rely on us. So I thought I would open with a little video here. This is a real video, and it's by a group called the Russian Cyber Army, perhaps Russian, and they did a little video of them hacking an HMI. And it's got this scary talking voice in sort of Russian. It's obvious the person running it doesn't really know what they're doing. They just sort of click around, and they change some limit switches, they cause a tank to overflow, etc. And this has got some people scared. And the question is, could that happen to me? If you go into shodan.io, which is a search engine for the Internet of Things, and you type in Rockwell, or you type in ignition, you find an awful lot of stuff that's available on the public internet. And it happens for a number of reasons, but the most common is somebody's used a port forward to get there. They're like, okay, that thing's in an inconvenient location. Nobody wants to drive out there late at night. Let's just put in a cellular modem with a port forward and call it a day. And that's really what they're talking about, is those people are relying on the built-in security of systems that are designed with negligible security. Yeah, it's got a 6-digit password, no username, and it's VNC. It should be fine, right? No, they're going to get into that almost right away. So that's your motivation. The overview, really it comes down to all industrial control systems have a very singular security model, which is called the air gap. And the idea is that outside bad, inside good. Or more accurately, outside infinitely bad, inside infinitely good. And the problem is this model is fundamentally insufficient. It doesn't mean you shouldn't have the concept there, but it's not enough. And the analogy that I use is you think about the human body. My skin is my firewall. It's what prevents bacteria from coming and killing me in my sleep. But if I get scratched, often by my cat, it's not going to kill me. And the reason is I have a secondary level defense called white blood cells. And that's really what you want to think about is defense in depth. Instead of having a single wall that's infinitely strong and putting all your effort into keeping it there, you want to think about having fallback levels of defense. Okay, they're going to get in through the firewall. They're going to get in through this. Okay, now they're here. You need telemetry to see that they're there. You need things to slow them down. You need mitigating measures for the stuff that you run that's kind of weak. Because, my friends, the stuff that's inside that industrial control system air gap is infinitely weak. And it means that you could put all your effort into this air gap, and then one person one day walks in with a USB drive that they found in the parking lot and plugs it in and blows the world up from the inside. Or somebody walks in with their laptop, they're on their corporate network, they're doing a bunch of email, they come inside, they plug it in, they're updating their iFix or something like that, and they blow it up. Or they've got a Wi-Fi in the plant and they blow it up. Or a vendor has a mistake in one of their upgrades and they blow it up. Or there's been a hole put in the air gap on the outbound direction so that a vendor can do license management and they blow it up, et cetera, et cetera, et cetera. And the key there is, because it's infinitely weak inside, you've got nothing. One of the strongest types of defense in depth is called multi-factor authentication. And the reason it's strong, multi-factor, is you need at least two of something I am, something I have, something I know. You can't have two from one category. It's no good to say, well, you've got a password and a PIN, or a password and a magic question about what your mother's maiden name was. That's just something you know. You need two different categories. And the reason it's strong is the risk of an attacker getting something from two categories are uncorrelated. So the risk that you've used the same password in 10 systems and one of them was breached is different than the risk that you left your phone on the bus and that's your second factor. So the attacker will be in one group or the other, but not both, and therefore multi-factor is very, very, very strong. Most attacks, so last year in the United States, they took all the federal agencies that had an attack and they rolled it all up into a big spreadsheet and yada, 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 and they gasketed it against something called the MITRE, attacks metric. And they found that more than 60% of attacks were something that had a type of valid credential and then moved laterally through the network. So it really comes down into credential management. Multi-factor is very strong, but it's also very non-obvious in a SCADA, HMI, RTU, VNC, RDP, ICS world, what that means, because multi-factor was designed around IT-based, OpenID Connect, web-based, and you have something that looks a lot more industrial. It doesn't have those protocols. I'm here to show you how to do that with an identity-aware proxy that will create that facade without reworking the device. So you think about those key systems, and there's lots of reasons that people need access to them, and you can define what the word remote means. Is remote within the same building? Well, there's 105 dBA on the other side of that door. I'm going to sit on this side of the door, thanks, with my single set of headphones on, not both. It can be another plant down the street. Well, we have a satellite plant. We've got a pumping station that's 10 kilometers away, and we'll just have microwave links between them or something like that. It can be elsewhere. It can be, hey, we're going to monitor this from our headquarters. We got a partner that does remote operations for us. Any of those things. Your HMI, it can be embedded, Rockwell panel view. It can be an OIT, like an industrial PC with a touch interface, running something like iFix, or it can be something that is a little bit more server-oriented, like VT SCADA or Ignition. It doesn't really matter. There's a legitimate reason that lots of people have to have either read-only or read-write access to an HMI. There can be IT-like things that are in the plant. The historian is the most obvious one that I run into, but also things like your iFix server and things of that nature. They're just a standard server. It's just in a different building. You've got things that are involved in development and engineering. So, for example, Rockwell Studio, I'm going to reprogram my PLCs. You've got all the supporting elements, your routers, your UPS, the building security, the cameras. These things support that infrastructure, and they often get forgotten, and they leak into the SCADA network because they're kind of in the same building and they're on the same switch, and maybe there's a VLAN and maybe not, and maybe there's a subnet and maybe there's not, but they're kind of treated as the same. And there's a real smorgasbord of protocols here. So SSH, RDP, VNC. The key is not a lot of it is HTTP 2.0, HTML, all the things that have advanced security appliances available for them. There's not a lot in this space. So the principle that I'm talking about today, before I get to the demo, is the idea of zero trust. And zero trust it's a very simple thing to understand. So the idea is, if every single resource, a resource is a thing, like an HMI, and person, if every one of those is pairwise authenticated and authorized, so HMI 2, Dawn is allowed read-only access between 2 and 5 p.m. That's zero trust. It means that you haven't given me any trust based on where I am, and you're not giving me any trust to anything else that's in the same building. So a VPN is the opposite. So a VPN is sort of like a long Ethernet cable. You're on the network, please be good, only talk to the HMI you're supposed to, don't run any network scans, thanks. That's not zero trust. So that's your problem when you have a more expansive network access than you need. You run into the risk of lateral traversal. While I'm having access to the entire network, instead of just the HMI I'm supposed to be touching, I'm clicking on my emails and I click on a phishing link and it starts doing something with scanning, and it scans through the VPN and it finds all this stuff. Zero trust is the opposite. You need three things to have zero trust. You need to have the who problem solved. Who are you? Identity. Never a shared identity. An identity is not a company. An identity is a person. So imagine that you work with, I don't know, Siemens. Siemens has 300,000 employees. It would make zero sense for you to have the Siemens vendor account with access to your network, because in the last couple minutes, I guarantee one of them was fired for bad reasons. That account cannot possibly be secure. You want to bring that account down to the person level, whether they work for you or not. And this means you don't want to create separate accounts where you've got a Joe at Siemens account and they have a Joe at Siemens account, because their HR team isn't going to call you when Joe leaves Siemens. So you got to figure out the who problem. Who are you? Who is this person? There's the authorization problem, the what problem. What are you allowed to do? So what is not the concept of just allowed to do anything you want. What is read-only access to HMI 2? That you need very fine-grained authorization there. And the last one is the access problem, or the how problem. How do I get you to that thing? So if you've solved who, what, and how on a per user resource basis with fine-grained authorization, you have zero trust. You can't achieve it with a VPN. You can't achieve it by just being on site and plugging into the network. You can achieve it with a segmentation approach in the network, ideally with identity as the key. So in the high-level user view, that's one of the things you want to think about here is, it's great to be more secure, but if my users can't adopt it or they're not going to be efficient, then it's not going to happen, right? So what we view as the worldview is a lot of people have a very singular task to do, and they want to do it from where they are with the device they have. So I just got paged that there's a problem. I want to open the HMI and look at the alarm. I'm in my truck. I'm on the side of the road. I got my kids in the back. We're on the way to vacation. I got a tablet and I'm going to use that. Thanks. That's what you want. You want to bring everything into a web-based world. And that's what I'm going to show you here, bringing VNC into a web-based world, SSH into a web-based world, even Rockwell Studio. It's a little bit more complicated, but bringing it into a world where the user can run Rockwell Studio on their desktop and talk to one PLC but not another, or two PLCs in two different customers at the same time, but nothing else, and do it through a web-based authentication model, which then gives you the single sign-on, the same as use your email and all those other things. You want those people to do it with their existing company login. So Dawn at Agilicus. You don't want me having to remember Dawn-their name at their company, because you know what's going to happen? I'm going to write my password on a piece of paper. And when I'm on vacation, I'm going to give it to my friend, because that's how it's going to work. You, the plant owner, need to manage the authorization. So you want to, your partners, you want them to control who the user is. You want to control what the user is allowed to do. And this is really designed for narrow task-based workers. We're not talking about zero trust as a way of the IT team with a need to access everything. We're really talking about the task-based worker who needs to, I'm your system integrator and there's a maintenance call and I'm changing this tag in this PLC to change the startup speed of some VFD or whatever jargon. And the main thing you want here is not to have any layer 3. No, you shouldn't be able to ping stuff. There shouldn't be the same routes. And that's a good thing. System integrators like that, because my laptop, I don't have to worry about overlapping IPs. I'll let you in a secret. Because of the air gap, every plant in the world runs the same IPs internally. And when you're a system integrator, the problem is they're the same as the IPs in your office, and you connect there and it doesn't work. So our system fixes that. So the key is to be secure for you, the end user, and simpler for everybody. So secure for the plant owner and simpler for their users. So what we're going to get to, and you'll see in the demo, is authentication, single sign-on by their company credentials. So if you're supported by Jane at company A and Joe at company B and you are company C, all three of you are going to sign in with your own credentials, just like you do your email. The reason that's secure is phishing. When you teach the user to have a single consistent sign-in experience, they'll recognize when there's something wrong with it. They'll recognize when they're being spearphished to try to go somewhere else. They also won't write down their credentials because they're the only ones with it. You should share your credentials with the same number of people you share your toothbrush with, which is none. There's no user provisioning and deprovisioning to worry about. So that in that model, when you leave that company, it just sort of stops because the company takes you out of their system. There's also a request acknowledge flow where somebody can say, hey, I need access, and you get pinged as an administrator, etc. So we'll switch into the demo, and maybe this will become a little bit more clear. The way we achieve this is with what's called an identity-aware proxy. So on the south side, in your plant, it speaks VNC and Ethernet IP and RDP and whatever you have there. And on the north side, it interacts with the user and identity and authorization, and it gaskets those two. So the user sees, I open a browser, I see a sea of icons, I click on the icon, my application works. And in the plant, they see nothing changed. I didn't have to reconfigure that device. That Rockwell panel view, VNC, RDP, HMI, yada, 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 no change to that. We're still able to program a PLC, check a tag, back up a database. There's no change to the process floor, no change to the embedded equipment. But we've migrated everything to use public identity. Now you can continue to use on-site identity as well as external. Some plants that we work with, they have a private Active Directory on site, and you can still work with that, and you can still do multi-factor with that. But the key is you're moving everything from a bespoke snowflake of how it authenticates to this modern web-based paradigm. And you can start seamlessly integrating your partners. And this is really good for mean time to repair. You call them and say it's broken. They say, what do I got to do? And you say, just go to this website and click, and now you'll see the same desktop I am. Oh, okay, I see your mouse moving. Let's talk it through together. You can give them read-only access. They can't click. You can click, and then you talk on it together. And it's amazing. You're deep inside what you thought was an air-gapped environment, and in real time, you've got an expert helping you with the problem. It's really quite good for you. So I'm going to switch to a really short demo. It's not very long. It depends on how long I make it, I suppose. Let's do share entire screen. And what you're going to see here, assuming I'm not lying to you, you're going to see, I'm just going to show the end user experience, none of the admin. You can contact me afterwards if you want to see the admin experience, but it's pretty. Okay, on to the demo. So we want the end user to have a very simple experience. We want their sign-in to be consistent with what they use day to day in the rest of their corporate life. We want to have a single tray of icons for everything they do. We really want to make it simple for them. So here we're talking about enabling multi-factor on a set of industrial applications. I'm going to demonstrate VNC and an HMI. There's different ways you could have multi-factor set up. You can have a push notification so your phone chirps, was this you? You can have it set up so you have a code generator. You can have it set up with passkeys. Here we're going to use the trust store built into my phone. You're going to see on the screen it pop up and say passkey. My phone will chirp and I'll press that off screen. So on the sign in, I have a lot of different ones here. You can have your own theming on this, but I'll let you in on a secret. 100% of your users have an account with either Google or Microsoft. The reason is they have a phone and they work for a company. So Microsoft account means Outlook.com, Office 365, Azure, Active Directory, and Google means Gmail or Workspace. This allows you to enable any user to sign in with something that's natural to them without you knowing the password for it, and it's per end user. I'm going to go ahead and use sign in with Google because we use Google Workspace. So click on that. You'll see the simple sign in. If you notice in the URL bar, this is Google's HTML. They own this. So we're delegating authentication to Google for the user. That doesn't mean we're giving Google permission to our plant. It doesn't mean that Google has any ability to do anything on our stuff. We own the authorization. So here I'm signing in, and you'll notice there was never a password asked for. If there had been, it would have gone back and forth to Google. The Agillicus NEX system has no passwords. There's nothing to breach there. Now I'm going to do the multi-factor. I've got it set up. I can use a code generator. I'm going to use the passkey on the phone. You'll see that it clicked. It went to my phone. I clicked, and I'm signed in. That was super easy for the end user. People will always complain, but there's not a lot of basis in the complaint here. Now we're going to show, there's a set of icons for each of the items. I won't spend too much time on them. Let me do a quick demo of VNC. It's right here in the browser, and boom, we're on a desktop, start menu, all that good stuff. This could have been anything. It could have been your Rockwell Studio. It could have been, VT SCADA. Speaking of VT SCADA, this is a web app. You'll see it opens in a new tab. For demo purposes, I have it set to ask for multi-factor on each of these, just because sometimes I forget and I'm signed in and then I didn't get it. But you would normally just have it once for the overall session. And then here the user is presented immediately as if they were on site. They could sign in. They could see the HMI. And speaking of HMI, we could have, this one is Node Red. Again, I've got the multi-factor turned on for everybody, but that's just for demo purposes so I don't forget. And, you're immediately in this. It wouldn't matter. You could be on a tablet. You could be on a phone. You could be pulled over at the side of the road. You could be on your desktop at work. It's just that simple. You can do a share. You can do a desktop application. I'm not going to demonstrate that today, but something like Rockwell Studio, it would go to your start menu. You'd click, a browser would open. You'd sign in. Rockwell Studio pops up. Boom, all the PLCs go active. And, we've got ignition and so on set up here. So that's my quick demo today. Thanks very much for watching it, and let me go back to the presentation. The extra multi-factor there, but I guess I had it turned on a bit aggressive. But that's the idea for the end user, whether it's a tablet or a mobile phone. They log in just like they log into their corporate email. They see an array of icons. They click on one. They have their job. They're doing it. They're not having to understand how remote access works. They're not having to bring up a VPN, which breaks their local printing. They're not having to change the IP address of their device. You're not worried about lateral traversal from them through, oh, they've got ransomware, it's coming through my share. It just doesn't work that way. So you think about how some of these protocols work, you break it down in these different categories. Sometimes we use remote desktop. VNC and remote desktop work the same way in that we're getting access to a host that has all the software on it and all the connectivity. There's pros and cons to this. So the pro is if that PC is going to be there anyway, this may as well happen. And secondly, you can now have a dual hands experience where you've got somebody helping you and you're both seeing it at the same time. Our system is an outbound only connection on HTTPS WebSocket. So it's really, really easy on your firewalls. There's no complicated port forwarding rules or things of that nature. It typically just functions. But this allows a person to teleport into the building. They're there seeing the same thing you do. When you have so that works well when you have the licenses of that end. That's the machine with Rockwell Studio and the licenses. If it's on your end, then you use the launcher that we talked about, or the direct access to the HMI. Sometimes when you're talking about PLC tags and you want to be monitoring them remotely, you can send the tags over this interface. Sometimes it's a backup, and you're using this to back up from using something like Veeam. Veeam is complicated. It's got a lot of security flaws. Another big one came out yesterday, 9.9. But people want to run it next to the thing they're backing up, right? But now it's in there, and if it gets, so what if you were to run it in a different network and use us for the segmentation and make it read-only, so data can flow towards Veeam but not the other direction? That's an example. Some of these others, VNC, it has a negligible native security. It's got a username, it's got a password but no username. The password is exactly 8 characters, and it's single DES encrypted. It means that the graphic card that you bought in 2008 can crack it in a second. It's negligible. So we enrich it. We become end-to-end TLS, 1.3, high encryption, single sign-on by a native identity provider. You saw I clicked, it was right there. Multi-factor, you can have read-only rules, etc. So what's needed to roll this out? I've talked a little bit about, you've got a bunch of things that you can't really change. They work the way they work. They achieve their business objectives. You got a bunch of people saying they need to be more secure, saying that multi-factor is the number one way they would like to see you implement. And you're looking at, square peg, round hole. Okay, I've got VNC with no username and a native 8-character password, and they're telling me they want single sign-on and multi-factor. And I'm saying I'm here to bridge that gap with no change on either side. The end user sees native web sign-in, the device sees VNC. Our connector acts as a proxy to facilitate this. You move the connector out and close to the VNC, nothing else gets past it, and away you go. The implementation becomes hours, not days. You know, in the time we've done this webinar, you would have had your first couple of things running and your first users using them. It's very, very simple. There's no network changes. There's no configuration changes because the proxy handles all the mapping for you. You get that very precise authorization. You know, this user gets read-only access. This user has read-write. This user gets access when I say so. The side effect of that fine-grained authorization is also fine-grained audit. You know who did what when, that trust but verify, and the end user gets a very seamless access. They don't have to worry about they have my VPN software installed. We've got a pre-shared key. None of that exists. They've gone and bought a tablet somewhere and they've opened it and it worked. And it worked because there's a browser on that tablet and the browser implements modern encryption or mobile phone or whatever. So my call to arms, by the way, if you have any questions, feel free to type them in the chat. Otherwise, just ask me at the end here. Call to arms. Look, there's a growing underserved thing here. Things are getting smarter. Your stuff in your plant is going to keep happening. Things are going to grow license servers and a need to talk to the cloud, and there's big data, and the building management system integrates with it, and yada yada yada, and wireless and 5G, and it's just going to keep moving. You can't be in the way of progress. You'll get rolled over by it. But by the same token, you don't have all the tools for security that you do in an IT world. You can't, Patch Tuesday and all those things are not a thing. So you're going to need a system like Agillicus NEX to act as that zero trust identity-aware proxy. Understand the VPN is not an appropriate solution for all. Your partners don't want to install your software. It creates a lateral traversal risk where stuff flows through it. That's what happened with the Colonial Pipeline attack in the United States a few years ago. One vendor, one VPN, and suddenly the gasoline supply of a G7 country is at risk. That's a big deal. Wars start over that. And that lateral traversal risk, when you talk about these industrial plants, they're typically one big subnet with nothing in it, and everything on it is as trusting as a newborn baby. Your lateral traversal risk is infinite if anything can pierce that air gap. Coming back to my skin, all it takes is one cat, one scratch, and you're in trouble. Understand that single sign-on and multi-factor is for everyone, not just your team. This is one of the big challenges I often see. We're going to roll out this for everybody that works for us. Well, you got all these other people that use stuff that have legitimate needs too. Screw them. Well, that's screwing you. Those people, they're your partners, whether they're the integrator that built it or the company that does remote operations for you, or it's a vendor that you're triaging some bug, or it's the developer trying to update the HMI or change a tag. They need single sign-on and multi-factor, A, for them to be convenient, but B, you need them to have it for you to be secure. No more shared accounts. If you have an account that two people know the password of it, there's a big problem. If you have an account that has the same password in two different systems, you have a problem. If you have systems that have local accounts, you have a problem. This is the fix for it. You move it all into the proxy layer. Love to talk with you guys. Engage with us any way you want. You can email me, don@agillicus.com. You can email the company. We got a whole bunch of resources online, some other case studies. Drew has posted it in one we did with the city of Kenosha, Wisconsin, in their public water system. We have another one online for the city of Midland, Texas, showing theirs, and another with the town of Mono showing theirs. But they're basically fairly similar. Somebody with a device needs access to an HMI for some reason with multi-factor and single sign-on. Somebody with a device needs access to reprogram a PLC from somewhere. Somebody with a device needs to come in and help me upgrade my historian. They're all very similar, and they all look kind of the same. Click, log in, single sign-on, multi-factor, sea of icons, click, use it, forget that the security thing's in the way, just focus on my task. With that, and seeing no questions, thank you very much for your time today. We'll send this recording out later. Again, love to interact with you. Feel free to reach out to us. Our team will reach out to you just to see what's on your mind. Thank you so much, and have a great day. Bye-bye.